Welcome to The Explainer. Today, we're diving into the story of an aircraft so unbelievably fast that its standard evasive maneuver against an incoming surface-to-air missile was literally just to hit the throttle and outrun it. We're talking, of course, about the Lockheed SR-71 Blackbird. Now, this is a machine that looks like it flew straight out of some distant sci-fi future. But here's the crazy part. It was engineered using slide rules and drafting paper, way back during the Cold War, before advanced computers were even a thing. These aerospace engineers somehow managed to bend the absolute limits of physics to build a reconnaissance plane that is still considered a complete marvel of modern history. To really put this plane's capabilities into perspective, get this. During its time operating over hostile territory, enemies fired an estimated 800 surface-to-air missiles at the SR-71 trying to bring it down. And the number of hits? Absolute zero. Not a single one. Merely hitting the gas was usually enough to evade any threat. By the time an enemy missile site could track the plane, get a radar lock, and actually fire, the Blackbird was already gone. The physics of the whole encounter were just incredibly skewed in the aircraft's favor. An ascending missile has to burn through its solid rocket fuel super aggressively just to fight gravity and reach that cruising altitude. So, the SR-71 simply pitched up, pushed the throttles forward, and left the exhausted missile falling harmlessly back down to Earth.
So, here is our roadmap for today. We're going to cover the origins, then look at the engineering behind this Mach 3 marvel, dive into its Cold War operational history, check out its NASA research and records, and finally, discuss its lasting legacy.
All right, let's jump right into Section 1, the origins of the Blackbird. Picture this. It's May 1960, and a U-2 spy plane piloted by Francis Gary Powers gets violently shot down over the Soviet Union. This was a massive international incident, and it immediately highlighted a really desperate need for a reconnaissance aircraft that wasn't sitting duck vulnerable. So, the CIA and Lockheed's super-secretive Skunk Works division, led by the legendary aerospace engineer Kelly Johnson, got to work. Their goal? Build an undetectable spy plane that flies higher and faster than anything else in existence. This kicked off Project Archangel, which first gave us the A-12, a plane meant strictly for covert CIA missions. But the U.S. Air Force needed a version for overt, clearly marked operations, and that's where the SR-71 comes in. It featured a heavier, longer airframe so it could carry way more fuel, and, crucially, it needed a two-person crew, a pilot up front and a reconnaissance systems officer in the back to handle all the complex sensors and cameras.
Moving right along to Section 2, engineering a Mach 3 marvel.
You have to understand, achieving sustained flight at more than 3 times the speed of sound presents some seriously monumental physics problems. Pushing through the air at those speeds generates insane amounts of friction, heat, and atmospheric shock waves. Plus, the Blackbird cruised at 85,000 feet. At that altitude, atmospheric pressure is basically non-existent. In fact, the crew was flying right near the Armstrong limit. That's the terrifying altitude where the boiling point of water drops below normal human body temperature. Which means, without protection, a pilot's blood would literally start to boil. Standard oxygen masks weren't going to cut it, so the crew had to wear these highly specialized, fully pressurized flight suits made by the David Clark Company. Out of pure physiological necessity, these were basically identical in function and design to the spacesuits worn by early astronauts.
You might have noticed the aircraft's incredibly unique shape, specifically those flattened, tapering sides running along the fuselage. Those are called shines. Originally, this brilliant aerodynamic quirk was added just to reduce the plane's radar cross-section by bouncing radar waves away from the source. But aerodynamicists quickly realized something amazing. Those shines generated powerful air vortices that washed right over the wings. This dramatically boosted lift and improved stability at lower speeds. So, this ridiculously fast, needle-like aircraft was actually quite flyable and wouldn't just drop out of the sky before hitting supersonic speeds. Now, cruising at Mach 3.2 essentially turned the aircraft into a flying furnace. Air friction pushed the windshield up to 600 degrees Fahrenheit, and the skin of the plane regularly topped 500 degrees. Since standard aluminum would just melt under that stress, 85% of the plane had to be built out of titanium. But that introduced a really wild engineering irony. The extreme heat caused the titanium to undergo massive thermal expansion. The whole plane would literally grow by several inches in flight. To deal with this, the fuselage panels were intentionally designed to fit together loosely while the plane was just sitting on the ground. Because of this, the world's most advanced aircraft notoriously leaked its specialized JP-7 fuel all over the runway right before takeoff. It only sealed up tightly once it got hot and expanded in the air. Oh, and to stop the plane from turning into a massive fireball on the runway, that JP-7 fuel was engineered with such a high flash point that you could literally drop a lit match into a bucket of it and the match would just fizzle out.
So what actually powered this titanium beast? The Pratt Whitney J58 engines were completely revolutionary. They were basically a hybrid design. During takeoff and at lower speeds, they functioned just like standard turbojets. But as the Blackbird pushed toward Mach 3, an incredible mechanical shift happened. Internal bypass tubes actively diverted the incoming air around the main engine core, dumping it directly into the afterburner. In really simple terms, the sheer forward velocity of the aircraft compressed the incoming air so violently that the engine morphed into a highly efficient ramjet. It used the plane's own speed as the ultimate high-speed compressor.
By somehow mastering both the thermal and aerodynamic puzzles, the SR-71 could effortlessly sustain a cruising speed of Mach 3.2. But, yeah, there was a catch. Because it leaked fuel on the runway and burned through an astronomical amount of fuel just climbing to its operational altitude and speed, the Blackbird almost immediately had to meet up with a specialized KC-135Q tanker plane in the sky. It was only after completely topping off its tanks midair that it could actually make its 2,200-mile-per-hour dash into hostile territory.
Which brings us to Section 3, Cold War Operational History.
Deployed all over the world, from Kadena Air Base in Okinawa to RAF Mildenhall in the UK, the Blackbird was absolutely packed with technology. It had side-looking airborne radar, massive wide-area optical cameras, and electronic intelligence sensors that just vacuumed up enemy radar frequencies and terrain data. One of its most famous and dangerous routes was dubbed the Baltic Express. Here, the SR-71 routinely gathered intelligence along the heavily defended Soviet coastline. The pilots had to thread the needle through a very narrow, incredibly sensitive corridor of international airspace wedged right between neutral Sweden and Soviet-controlled East Germany, all while being constantly shadowed by hostile interceptors.
Now, while it was practically untouchable by the enemy, it wasn't immune to mechanical issues. In a really dramatic incident back in 1987, an SR-71 suffered a catastrophic engine explosion way up at 66,000 feet. The crippled spy plane rapidly dropped out of the sky and limped into Swedish airspace. Unarmed Swedish Viggen fighter jets immediately scrambled to intercept. When the Swedish pilots realized this legendary American spy plane was in deep distress, they bravely formed a protective shield right around it. They actively escorted the damaged Blackbird out of the Baltic Sea, defending it from a pursuing Soviet MiG-25 that had actually locked a live missile onto the vulnerable aircraft.
Out of the 32 SR-71s ever manufactured, 12 were lost to accidents during its operational lifespan, which is honestly just a stark reminder of how insanely unforgiving it is to fly at the absolute edge of space. But thanks to its mind-bending speed, its altitude, and the occasional assist from friendly neutral nations, the number of Blackbirds lost to enemy action remains exactly zero. When it came to adversarial threats, Kelly Johnson's design was completely flawless.
Let's look at its second life in Section 4, NASA Research and Records.
As the Cold War finally started to cool down, the Blackbird transitioned from a top-secret reconnaissance tool into an absolutely vital asset for aeronautical science. NASA actually utilized loaned SR-71s from the Air Force, basically using them as the ultimate extreme environment testbeds. Because they could consistently cruise above 80,000 feet at Mach 3, scientists could gather unprecedented data on sonic booms, high-altitude atmosphere, and advanced aerodynamics. They were essentially paving the way for the next generation of hypersonic aircraft.
By the late 1990s, NASA turned the Blackbird into a literal flying wind tunnel. Engineers would strap experimental hardware right onto the back of the aircraft to see how totally new concepts held up in actual stratospheric conditions. A great example is the LASRE experiment. They mounted a linear aerospike engine model, this radical, nozzleless rocket design meant for future spaceplanes, right on the plane. This let them gather aerodynamic data during real high-speed flight that ground-based wind tunnels just couldn't replicate.
And let's not forget, when the aircraft faced its initial military retirement in 1990, it didn't just quietly bow out. It set 4 blistering transcontinental speed records that still stand today. It blasted across the Atlantic from New York to London in under 2 hours. And even crazier, it flew from Los Angeles to Washington, D.C. in exactly 64 minutes, averaging over 2,144 miles per hour. Just think about that for a second. The Blackbird crossed the entire North American continent faster than a standard morning commute in either of those cities. Absolutely mind-blowing.
Finally, we arrive at Section 5, the Blackbird's legacy.
The decision to permanently ground the Blackbird was actually one of the most fiercely debated topics in modern military aviation. It really highlighted the split between political budgets and tactical reality. On one hand, politicians argued that the plane was just too expensive to operate and claimed it was being made totally redundant by new surveillance satellites and the rise of unmanned drones. But on the other side, a lot of military commanders pushed back hard. They argued the satellites are totally predictable. Enemies know exactly when a satellite is flying overhead, so they just hide their stuff until it passes. The SR-71, however, brought unmatched tactical surprise. It could be routed anywhere, anytime, giving commanders immediate and unpredictable intel that no satellite could ever provide.
Because of this intense strategic debate, the plane's retirement timeline is pretty fractured. The Air Force initially retired it in 1989. Then, Congress actually forced them to reactivate 3 of the aircraft in the mid-1990s to fill some reconnaissance gaps. But eventually the funding arguments won out. The Air Force officially and permanently retired the SR-71 in 1998, and NASA flew its final scientific research flight in October 1999, closing out a truly legendary chapter in aviation history.
Today, modern intelligence gathering is completely dominated by drones and satellites. But there is always talk about the future. Lockheed Martin has floated the idea of a Mach 6 unmanned successor, casually known as the SR-72. But right now, it's heavily shrouded in concept art, whispers, and speculation. So it leaves us with a huge question. Will these proposed hypersonic successors ever actually take to the skies? Or will the SR-71 forever remain the untouchable, singular pinnacle of aviation? It's a fascinating mystery that keeps us all guessing. Thank you so much for joining me for this explainer. I hope you found this deep dive as incredibly fascinating as I did.